Lesson 13.3 is Riemann and trapezoidal sums from equations. So we've done them from graphs themselves, which were the easiest. Tables, at least you already had the points. Now an equation, we don't even have the points. So we'll have to make our own table to then be able to find the area of the rectangles. So f this time is a function. It's 6 over x. And so we'll have to plug in x values to know what y is at those certain x values, and sometimes it gets a little complicated. We're definitely going to have to do some rounding here. They specifically tell us that 3 sub-intervals of equal length. All of these will be of equal length. What is the value of the left Riemann sum approximation? We're going from 2 to 6.5. So what I would do is go ahead and make a table. X comma f of x, we'll just keep it going horizontal like our other ones were. We want to go start at 2. And first I would then figure out, well, how wide are my intervals? And to do that, you take your b minus your a. This is your b value, this is your a. So what is the distance from 6.5, or from 2 to 6.5, I should say. You don't need a calculator for that. That's 4.5. And then divided by how many sub-intervals they want. So what's 4.5 divided by 3? It's 1.5. So we're going to have to make all of our rectangles be 1.5 for their width, which means that's what the x values will change by. So they call that change, or delta x, change in x. So 2 plus 1.5 would be 3.5, will be our next x value. 3.5 plus 1.5 would be 5. 5 plus 1.5 would be 6.5. And that'll finish out our table. Okay, so now I have to plug in x is 2. So this one's not bad. 6 divided by 2 is 3. So I could do that, or you could just say it's f of 2 if you want, but this one's not too bad. Next one, I'm gonna have to plug in 3.5 here, so 6 divided by 3.5. And it tells me to round to, I'm gonna zoom out a little bit. It tells me to round to the nearest thousand. So I guess I'll go ahead and round these to a 10,000ths place. So I'll do 1, 2, 3, 4. 1.7143. Okay, 6/5 is 1.2. That's a nice one. And then 6 divided by 6.5. 0.9231. Okay, so from there, I'm doing a left Riemann sum. So I want the points on the left side. So I'm not going to even use that one. And if you know that ahead of time, then you wouldn't even have to find it. Okay, so to find my area, I know that every time my change in x is 1.5. So instead of having 1.5 times something plus 1.5 times something plus 1.5 times something, you could actually just say it's 1.5 times the sum of all of these things, which I find easier. So it's going to be a 1.5 width for a rectangle with a height of 3, and a rectangle with a height of 1.7143, and then 1.2. So it just basically factors out a 1.5, or it changes the order of operations, but does the same thing. 7,143 plus. So get that total, take it times 1.5. So that's 8.871. Would be your total area. And I just want to show you that if I were to do this, I would get the same answer. So it's your preference. And then again, that only works when the sub-intervals or your rectangles are all the same width. All right, number 2. F is a new function. It's x to the 4th power, so it could get pretty big pretty quick. If 5 sub-intervals of equal length are used, what is the value of the midpoint? Midpoint Riemann sum. So we're going to actually need to find a middle here. We're only going from 0 to 2. So let's make a table. Starting at 0. Let's figure out our change in each rectangle. So we'll take our b minus our a. 2 minus 0 is 2. Divided by how many sub-intervals is 5. So yuck that we get 2/5. But 2/5, I'm just thinking in my head here, is the same thing as 4/10, which I know as a decimal is read as 0.4, 4/10. So without a calculator dividing that, I know this is 0.4. So that's what I'm increasing by. But since this is a midpoint, I actually need to have another number in between. So this is actually going to be my width, but I'm going to need the middle y value. So halfway between 0 and 0.4 would be 0.2. So then again, I'm going to have, oh gosh, this table's going to get big because I've got 5 of them. Okay, so there's 1. And then I'm going to have, really, I'm just counting by 0.2, 0.6. So this will be my y value I use. This will be my y value I use. This is my second. Yeah, yuck. Okay, this will be 1. This will be 1.2. So there's my, hold on, 0 to 0.4, 0.4 to 0.8, 0.8 to 1.2, 1.2, to 1.6, and then 1.6 to 2. Little circle. Okay, so that's 1, 2, 3, 4, 5. Okay, you wouldn't really even need this. You would just need the midpoint values, because to find your area, you know that every width is 0.4. All you need to know is what are all 5 of these heights. So then you're simply plugging in 0.2 to the 4th. And I don't know that I even want to, I'll just say f of 2, or 0.2, sorry. F of 0.6, f of 1, which that's easy because 1 to the 4th is still 1. F of 1.4, and f of 1.8. Sorry, yuck. Okay, so then I'm going to have 0.2 to the 4th power plus 0.6 to the 4th power plus, I'm just going to put 1, plus 1.4 to the 4th power plus 1.8 to the 4th power. So that should be 1, 2, 3, 4, 5. And taking that all times a width of 0.4. Okay, and I ended up getting 6.188 for total area. All right, then the last one is going to be our trapezoidal sum. I thought it'd be a good one to do. We're going to divide this into 4 sub-intervals. We're going from 0 to 2. So let's make our table. Let's figure out our change in x. So 2 minus 0 divided by our 4. That would be 2/4, which is a half. 0.5, so that's what we're going to count by. Okay, you can count. Okay, 1.5. I was like, how am I missing one? I've done way too much math today. All right, and then 2. There we go. Okay, 6 to the x power. So this is 6 to the 0 power, 6 to the 0.5 power, 6 to the 1st power, 6 to the 1.5 power, 6 squared. I know anything to the 0 power, this is 1. I know 6 to the 1st, this is 6. I know 6 squared is 36. These, though, this is 1/2. That's a square root of 6, which is going to be a decimal. That's 3/2. That's a square root of 6 cubed. I would just leave it like that. Okay, so trapezoids. Trapezoids, we're going to have a common height every time. That was like this problem. Our x values, our change in x is our height of our trapezoid. Then we're going to need the bases. Well, look, this is base 1 is going to get used once. Well, then they overlap. So this base gets used for the bottom of the first trapezoid and the top of the second. And then this one gets used for the bottom and the top of the next trapezoid. They all overlap except for the first base and the last base. So a way that you could do this is go ahead and have your common change here, that 0.5. So this is to find our area. The 0.5 for the width, or the height of the rectangles, I should say. You're averaging the bases. which means you're adding them all up and dividing by 2 or taking times a half. I could actually times a half again in front of the whole thing, kind of like I'm doing with this, is just take it in front of the whole thing, and then all I would have to do is add up all the bases. Well, I told you this only occurs once, and this only occurs once, but then everything else inside will be twice because they'll share. So I'll have a height of, or a base of 1. I'll have 2 of the square roots of 6. I'll have 2 of the 6's. I'll have 2 of the 6 to the 1.5 or 3/2 power, and then I'll only have plus 1 of the 36. So that to me, trying to do these quickly is faster. So I know half of a half, this is going to be a fourth or 0.25. I do know that. So I have 1 plus 2 times square root of 6. It's just 2 square roots of 6 plus 2 6's would be 12 plus 2 times 6 to the 1.5 power plus a 36. And that's 83.2929 times a quarter of that should give me a total area of 20.823. So again, you do it however you want. If you want to go and have all of the different triangles getting divided by 2, that's fine. I'm basically factoring out this 1/2 and bringing it in front so I don't have to do it to every single one. And then from there, it's just adding these bases up and knowing which ones are going to show up twice and which one I only need to add in once.